It will be a very long time before that venture turns into a reality, on the off chance that it goes as expected. The journey to Proxima B will take about 20 years, so practically, it will be a very long while before we can affirm if there is, without a doubt, life on that planet. Music. Proxima B is Earth-like. So what makes Proxima B fascinating is that it's an Earth-like planet circling the closest star to the Sun. The most clear picture of Proxima B ever delivered by the James Webb Telescope gives surprising new data about this possibly habitable exoplanet. Join us as we head out through space to tackle the mysteries surrounding Proxima B and check if it holds the potential to be the future Earth. Come on, let's go. The great exoplanet, a mysterious planet called Proxima Centauri, is situated in the habitable zone of its star, deep inside the vastness of space. Proxima Centauri B isn't just any old space rock, it's the relative of Earth. This planet, which is only 4.2 light-years away from Earth, is a mystery and a marvel. Is it a second Earth, one with oceans and a plethora of life flourishing on its surface? Yet there's still more. The super-Earth Proxima Centauri C is Proxima Centauri B's companion on its orbit around the red dwarf star. Who knows what further secrets this celestial system covers? Potentially even another unseen companion. The energy that Proxima Centauri B receives from its star is practically identical to that which our planet gets from the Sun. Does this imply that there is water, perhaps even life, on its surface? Exoplanets, or planets that circle stars other than the Sun, are an entirely different world that we discover as we travel beyond our own solar system. The universe contains 206 trillion stars. Therefore, the possibilities of finding exoplanets are innumerable. Like solitary space travelers, some exoplanets even journey the universe unattached to any star. Proxima Centauri B is the most unusual and puzzling planet of them all. One side of the planet is likely always bathed in light while the other half is in eternal darkness. Since the planet has a year that lasts just 11.2 Earth days, it is found multiple times closer to its star than Earth is to the Sun. The focal point of consideration is a part of the Alpha Centauri triple star system. Proxima Centauri B rotates around the red dwarf Proxima Centauri, the nearest star system to our solar system, which is comprised of Rigil Kentaurus, also known as Alpha Centauri A, Alpha Centauri B, and Proxima Centauri, also known as Alpha Centauri C. The third brightest star in our night sky, Rigil Kentaurus and Alpha Centauri B, are the stars that make up the binary Alpha Centauri AB. These G and K-type stars appear as one star in the Pictor constellation. The red dwarf star Proxima Centauri, sometimes referred to as Alpha Centauri C, is situated 0.21 light-years away from the other two stars, or nearly 500 times farther away than Earth is from the Sun. Scottish astronomer Robert Thorne discovered it in 1915, making it the star closest to Earth. Despite being our closest stellar neighbor, its apparent magnitude of 11.13, much higher than the naked eye's limit of 6.5, means that it is invisible to the unaided eye. Proxima Centauri and other red dwarf stars are among the most useful sources of energy. Their internal convection processes keep them burning for trillions of years, even though they do not produce a lot of energy for a further 4 trillion years. Proxima Centauri will continue to be a main sequence star. However, it is still in question whether a red dwarf star like Proxima Centauri is habitable. It is a flare star that varies frequently and unpredictably. Its habitable zone, estimated to be between 0.023 and 0.054 Australian dollars, is closer to it than it is to the Sun. In spite of being in this zone, Proxima B is exposed to many times more extreme UV radiation from its star than we are from our Sun. The life-giving chemicals could be annihilated by this strong radiation. As part of the James Webb Telescope, JWST, the investigation into Proxima B's true nature continues. After various delays, the James Webb Telescope was finally launched in 2018 to examine the possibility of life on Proxima B. The telescope is capable of observing infrared light, which enables it to detect light that Proxima B may retransmit if it absorbs light from its star. The ability to perceive water or an atmosphere is crucial. Proxima B might resemble Venus in having a thick, hostile atmosphere. Therefore, even if it has an atmosphere, it does not necessarily mean that life exists there. One of the JWST's limitations is that the presence of an atmosphere does not always imply that life exists there. It is possible that Proxima B has a hot, humid atmosphere that is unsuitable for life. Even yet, if artificial light reaches 5% of the brightness of the dayside, the JWST can detect it, a significant capability considering that Proxima B's star is far fainter than our Sun. Brilliant circling mirrors could be utilized by Proxima B's conscious development to reflect sunlight to the planet's night side. Getting to Proxima B is difficult. The Proxima Centauri system is the closest exoplanet to Earth, but it would take a spacecraft like Voyager 275,000 years to reach it. However, solar sails, which accelerate spacecraft by harnessing solar pressure, could cut the travel time to just 20 years. With this technology, the problem of running out of fuel is solved, and interstellar travel may become possible. Exoplanets flourish, and they are just waiting to be viewed. These planets range in size and structure from enormous gas giants to planets that resemble Earth. Superjupiters, which dwarf even the largest planets in our solar system, are examples of gas giants that are larger versions of massive planets like Jupiter and Saturn. Gas giants known as hot Jupiters orbit fiercely close to their host stars, reaching temperatures high enough to melt metal. Imagine being on such a world with its violent storms and searing temperatures. The discovery of Proxima B has revived human interest in space travel and given us hope that we are not alone in the universe. Although the JWST has limits, its capabilities represent a significant advancement as we continue our quest to uncover the mysteries of distant worlds. We are still traveling to Proxima B and other exoplanets because we want to learn more about and understand the universe. The clearest picture of Proxima B ever delivered by the James Webb Telescope provides alarming new data about this possibly habitable exoplanet. Join us as we journey through space to tackle the mysteries surrounding Proxima B and check if it holds the potential to be the future Earth. Come on, let's go. The sublime exoplanet, a mysterious planet called Proxima Centauri, is situated in the habitable zone of its star, deep inside the vastness of space. Proxima Centauri B isn't just any old space rock, it's the relative of Earth. This planet, which is only 4.2 light-years away from Earth, is a mystery and a marvel. Is it a second Earth, one with oceans and a plethora of life flourishing on its surface? Yet there's still more. The super-Earth Proxima Centauri C is Proxima Centauri B's companion on its orbit around the red dwarf star. Who knows what further secrets this celestial system covers, potentially even another unseen companion. The energy that Proxima Centauri B receives from its star is practically identical to that which our planet gets from the Sun. Does this imply that there is water, perhaps even life, on its surface? Exoplanets, or planets that circle stars other than the Sun, are an entirely different world that we discover as we travel beyond our own solar system. The universe contains 206 trillion stars. Therefore, the possibilities of finding exoplanets are innumerable. Finding exoplanets is innumerable, like solitary space voyagers. Some exoplanets even journey the universe unhindered, unattached to any star. Proxima Centauri B is the most surprising and puzzling planet of them all. One side of the planet is most likely continuously washed in sunlight, while the other half is in unending haziness. Since the planet has a year that endures just 11.2 Earth days, it is found multiple times nearer to its star than Earth is to the Sun. Proxima Centauri B is the focal point of consideration as a part of the Alpha Centauri triple star system. Proxima Centauri B spins around the red midget Proxima Centauri, the nearest star system to our planetary group, which is comprised of Rigil Kentaurus, otherwise known as Alpha Centauri A, Ptolemy, sometimes known as Alpha Centauri B, and Proxima Centauri, otherwise known as Alpha Centauri C, the third most brilliant star in our night sky. Rigil Kentaurus and Ptolemy are the stars that make up the parallel Alpha Centauri AB. These G and K-type stars appear as one star in the Centaurus constellation. The red dwarf star Proxima Centauri, at times referred to as Alpha Centauri C, is arranged 0.21 light-years from the other two stars, or about 13,000 times further away than Earth is from the Sun. Scottish astronomer Robert Thorne discovered Proxima Centauri in 1915, making it the star nearest to Earth. Despite being our closest star neighbor, its apparent magnitude of 11.13, much higher than the naked eye limit of 6.5, means that it is imperceptible to the unaided eye. Proxima Centauri and other red dwarf stars are among the most useful sources of energy. Their inner convection processes keep them consuming for trillions of years, despite the fact that they do not produce much energy. For a further 4 trillion years, Proxima Centauri will continue to be a primary sequence star. It is still up for debate, however, whether a red dwarf star like Proxima Centauri is habitable. It is a flare star that changes frequently and unpredictably. Its habitable zone, estimated to be between 0.023 and 0.054 Australian dollars, is closer to it than it is to the Sun. Nonetheless, being in this zone, Proxima B is exposed to many times more extreme UV radiation from its star than we are from our Sun. The nurturing chemicals could be annihilated by strong radiation. Some portion of the James Webb Space Telescope, JWST, research concerning Proxima's real essence goes on in spite of its difficult conditions. After various delays, the JWST was finally launched in 2018 to explore the plausibility of life on Proxima B. The telescope is capable of noticing infrared light, which enables it to detect light that Proxima B may re-emanate if it absorbs light from its star. The ability to perceive water or an atmosphere is essential. Proxima B may resemble Venus in having a thick, hostile atmosphere. Consequently, regardless of whether it has an atmosphere, it does not necessarily imply that life exists there. One of the JWST's deficiencies is that the mere presence of an atmosphere does not always mean that life exists. It is conceivable that Proxima B has a hot, muggy atmosphere that is unsuitable for life. Even yet, if artificial light reaches 5% of the brightness of the day side, the JWST can recognize it, a noteworthy capability, given that Proxima B's star is far fainter than our Sun's splendid circling mirrors could be utilized by Proxima B's advanced civilization to reflect sunlight to the planet's night side. Reaching Proxima B is difficult. The Proxima Centauri system is the nearest exoplanet to Earth, but it would take a rocket like Voyager 2 about 275,000 years to arrive at it. However, solar sails, which accelerate rockets by harnessing solar pressure, could cut the trip time to just 20 years. With this technology, the issue of running out of fuel is settled, and interstellar travel may become conceivable. Other exoplanets, Neptunian or Neptune-like exoplanets, which have sizes comparable to Uranus and Neptune, exist alongside gas giants. These include hot Neptunes and small Neptunes, which are smaller than their gas giant cousins and dwell closer to their host stars. These planets are often hidden in obscurity, and it is challenging to explore their environments from a distance. The terrestrial exoplanets, which resemble Earth, should also not be disregarded. These planets range in size from less than our planet to twice as large in radius. Super-Earths exist that are lighter than Neptune but have masses over 2 times that of our planet. Proxima Centauri b, an exoplanet that orbits the star of the same name, is one of the most intriguing discoveries lately. With a mass of nearly 7 Earth masses, this planet is classified as a super-Earth. It is excessively far away to be considered in the habitable zone, despite being close to its host star. Proxima Centauri c is a companion star of Proxima Centauri b. However, it is much farther away. This planet was discovered in 2020 using pre-recovery Hubble data and has an orbital period of around 5.5 Earth years. Maybe as a result of a ring structure, Proxima C seems to be a very splendid world. A change in Proxima C's radial speed was observed by researchers in 2019, which could hint at the presence of another planetary companion. Whenever confirmed, Proxima Centauri d will be the name given to this planet, which will be about the size of either Mars or Mercury. Imagine a universe wherein the evening sky is occupied by innumerable planets, each with a unique composition and orbit, alongside stars. Discovering extraplanets, exoplanets, is only one of the many wonders of the universe. Astronomers are living in an exciting era, with new discoveries being made on a regular basis. Like the stars that light up the sky, we know exoplanets exist, even though we do not yet have a precise count of them. Exoplanets, however, are difficult to notice and track down exoplanets. Huge telescopes and state-of-the-art gear are essential. These instruments are trying to inspect these planets, as the glare of their host stars often darkens them. With some of the best telescopes on the planet, direct imaging of exoplanets is currently possible due to innovative advancements. An exoplanet must be sufficiently large to be seen with a telescope far enough away from its host star to avoid being dazzled by its glare and young enough to be hot and apparent from Earth for straightforward imaging. These requirements limit the number of exoplanets that can be directly captured, yet they provide a fascinating window into the properties and composition of these distant worlds. The most frequent method for finding exoplanets is by observing the changes they cause in their host stars. Cosmologists can detect the radial velocity of a wobbling host star caused by an exoplanet's gravitational pull. The transit method, which examines a star's light diminishing when an exoplanet passes before it, was used by the Kepler Space Telescope. The size, distance, and temperature of exoplanets have all been significantly improved by this method. Here are a few fascinating statistics. Earth-sized planets can be found in the habitable zones of nearly 22% of stars like our Sun, and 7 rocky exoplanets with water on their surfaces can be found on TRAPPIST-1. Exomoons are naturally occurring satellites that can exist on exoplanets, just like those in our solar system. We currently know that exoplanets are abundant across the universe, having been detected on more than 4,000 of them. Many more exoplanets are out there waiting to be discovered. However, hot Jupiters are the easiest to observe due to their mass and rapid rotation. Each discovery provides a new perspective on the universe. NASA's James Webb Space Telescope is uncovering the secrets of the universe, revealing previously unseen phenomena. This astonishing telescope has been gathering data and taking amazing photos of the cosmos. It recently made a groundbreaking discovery that will forever change our view of the universe. According to NASA, the James Webb Space Telescope has found the first substantial proof of carbon dioxide in a planet's atmosphere that isn't in our solar system. This revelation provides significant insights into the structure and evolution of the planet, furnishing us with a window into the secrets of the universe. The discovery of this gas giant, located 700 light-years from a sun-like star, represents a significant advancement in the search for extraterrestrial life. Astronomers and scientists worldwide are excited about this finding, as NASA Administrator Bill Nelson promised to provide us with a new perspective on the universe that we have never seen before. But that's not all. The James Webb Space Telescope has been diligently taking stunning pictures and learning about the universe. The discoveries continue to come, and the breathtaking images of dust clouds, galaxies, and stars interacting are absolutely astonishing. Using the telescope, an international team of space experts conducted a comprehensive inventory of the coldest, deepest ice yet detected in a molecular cloud. They found frozen forms of various molecules, including water, carbonyl sulfide, ammonia, and methane, in addition to some complex organic compounds like methanol. This thorough inventory offers invaluable insights about the beginnings of planets and stars that will exist in the future. An image taken by the telescope's near-infrared sensor showed the 630 light-year distant chameleon Briam, a dark molecular cloud. Wispy cold cloud material is illuminated in the infrared by radiation from the energetic outflowing protostar, said 110 IRS-4. The light from distant stars absorbed by the cloud's ice appears as orange spots behind it. Webb's Ice Age project, which aims to study the evolution of ice from its origin to the age of icy comets, incorporated these astounding discoveries. The James Webb Space Telescope also imaged a nearby red dwarf star in the infrared for the first time, recreating the inner dynamics of a dusty disk surrounding it. This discovery could shed light on how planetary systems develop and help us understand the origins of our own solar system. The James Webb Space Telescope reveals more secrets about the universe with each new finding, and we are eager to see what else might be discovered in the future. There are countless possibilities available, and the secrets of the universe are just waiting to be uncovered. How do you feel about this? Tell us in the comments, and we'll converse with you then.